Have you ever wondered how our body fights stress and inflammation? Well, the answer lies in a group of hormones known as adrenocorticosteroids, a fascinating topic that we'll be exploring today. Adrenocorticosteroids are steroid hormones produced in the adrenal cortex, a part of our adrenal glands which sit atop our kidneys. These hormones play numerous critical roles in our body, maintaining various physiological processes, and are absolutely essential for our survival. Imagine these hormones as our body's personal superheroes, always on guard, ready to save the day. They regulate our metabolism, immune response, and help our body respond to stress. Stress here doesn't just mean a hard day at work or an upcoming exam. It also includes physical stress, such as injury, illness, or surgery. Inflammation is another area where these hormones show their power. They control the body's inflammatory response, ensuring it doesn't go overboard and start causing more harm than good. They're like the referees of a football match, keeping everyone in check and ensuring fair play. Understanding adrenocorticosteroids is particularly important for medical students because these hormones are commonly used in medicine. They're involved in treatments for a range of conditions, from asthma and allergies to autoimmune diseases and cancer. So, if you're studying medicine, getting to grips with these hormones could be a game changer for your future career. But of course, like all superheroes, adrenocorticosteroids also have their villains. These are known as corticosteroid antagonists, substances that block the action of adrenocorticosteroids. And just as every superhero story needs a villain, every discussion of adrenocorticosteroids needs a mention of these antagonists. So we'll also be taking a look at these characters, exploring their role in the body and how they interact with adrenocorticosteroids. But that's a story for another scene. For now, we've set the stage, introduced our main characters, and given you a glimpse of the adventure that awaits. Stay tuned as we dive deeper into the fascinating world of adrenocorticosteroids. Where do these adrenocorticosteroids come from, you ask? Well, let's dive right in. It all starts with a molecule we're all familiar with, cholesterol. This humble molecule, often vilified in discussions about diet and health, is the starting point for the biosynthesis of adrenocorticosteroids in the adrenal glands. In the adrenal glands, which sit atop our kidneys like little hats, cholesterol is converted into pregnenolone via an enzyme known as P450-SCC. This conversion is a crucial step, as pregnenolone is a parent compound for all steroid hormones. Pregnenolone then undergoes a series of transformations. First, it's converted into progesterone, another hormone you might be familiar with. This conversion is driven by an enzyme called 3B-HSD. Now, progesterone isn't our final product, but it's an important stepping stone in the pathway. The next step is where things start to get interesting. Progesterone is converted into 11-deoxycorticosterone by two enzymes, 21-hydroxylase and 11-B-hydroxylase. This molecule is a precursor for the mineralocorticoids, a group of adrenocorticosteroids that play a key role in regulating electrolyte balance in our bodies. But we're not done yet. 11-deoxycorticosterone can be further converted into corticosterone, another adrenocorticosteroid. This conversion is again driven by 11-B-hydroxylase. Corticosterone is the primary glucocorticoid in many animals, although in humans it's usually further converted into cortisol, the primary glucocorticoid in our bodies. And there you have it. From cholesterol to cortisol, the biosynthesis of adrenocorticosteroids is a complex but fascinating process. It's a testament to the incredible machinery of our bodies, transforming a simple molecule like cholesterol into a hormone that plays a crucial role in our response to stress, our metabolism, and our immune system. So that's how our body creates these incredible hormones. But how do they work? Now let's unravel the mystery of how adrenocorticosteroids function. Adrenocorticosteroids are a group of hormones produced by the adrenal cortex, a part of our adrenal glands. They play a crucial role in our body's response to stress, inflammation, and many other physiological processes. These hormones work through a fascinating mechanism known as gene transcription and protein synthesis. Let's break it down. Adrenocorticosteroids are lipophilic, which means they can easily cross cell membranes. Once inside a cell, they bind to intracellular receptors, specifically the glucocorticoid and mineralocorticoid receptors. These receptors are found in the cytoplasm of the cell, just hanging out, waiting for the hormones to arrive. When the hormones bind to these receptors, they trigger a change in the receptor's shape, activating them. This activated hormone receptor complex then migrates to the cell's nucleus, where our DNA resides. Inside the nucleus, this complex binds to specific regions of DNA called hormone response elements. This binding initiates the process of gene transcription, where the DNA's information is copied into messenger RNA or mRNA. This mRNA then travels out of the nucleus and into the cytoplasm, where it guides the creation of specific proteins through a process called protein synthesis. These proteins can be enzymes, structural proteins, or even other hormones, each playing a vital role in the body's physiological functions. So you see, adrenocorticosteroids are like the conductors of a cellular orchestra, directing the production of proteins that dictate how our bodies respond to a variety of conditions, from inflammation and immune response to the regulation of our metabolism and blood pressure. But as with all things, balance is key. These hormones must be produced in the right amounts for our bodies to function optimally. Too much or too little can disrupt the delicate harmony of our body's processes. Intriguing, isn't it? But what happens when there's too much or too little of these hormones in our body? So stay tuned as we delve deeper into the effects of abnormal levels of adrenocorticosteroids in our next scene. Imbalance of any kind can lead to problems, and it's no different with adrenocorticosteroids. It's like a seesaw. You need just the right amount of weight on both sides for it to work correctly. Too much or too little, and the seesaw tips. This is where corticosteroid antagonists come into play. Corticosteroid antagonists, as the term suggests, work against corticosteroids. They're like the counterweights on our metaphorical seesaw, helping to regulate the levels of adrenocorticosteroids in the body. These antagonists bind to the same receptors as adrenocorticosteroids, blocking their actions and thus maintaining a balanced hormonal environment. Let's dive into some common examples of these antagonists, shall we? First up is mifepristone, a notable glucocorticoid antagonist. It's often used in the medical field for its ability to terminate early pregnancies, but it also shows promise in treating Cushing's syndrome, a disorder caused by an overproduction of cortisol. Next, we have spironolactone, a mineralocorticoid antagonist. It's a star player in treating conditions like hyperaldosteronism and hypertension. By blocking the actions of aldosterone, it helps control high blood pressure and the balance of electrolytes in the body. Then there's ketoconazole. Now this one's a bit different. It's an antifungal medication that also inhibits the synthesis of corticosteroids. So, while not a direct antagonist, it still plays a role in keeping those corticosteroid levels in check. These are just a few examples of the many corticosteroid antagonists out there. Each one plays its part in maintaining the delicate balance of hormones in our bodies. They may not always be front and center in the limelight, but their roles are crucial in the grand scheme of things. So next time you think about the balance of your body, remember these unsung heroes? They're quietly working in the background, ensuring everything runs smoothly and stays in balance. Corticosteroid antagonists, the unsung heroes in our battle against hormonal imbalances. Let's take a quick journey through the world of pharmacology related to adrenocorticosteroids and their antagonists. We've learned about their biosynthesis and mechanisms of action, but what happens when these hormones enter our bodies as medicine? Adrenocorticosteroids are usually administered orally, intravenously, or topically, depending on the condition being treated. For instance, a person with inflammatory skin conditions might be prescribed a topical corticosteroid cream. Once administered, these hormones don't just stay put. They're distributed throughout the body, guided by the circulatory system. They're lipophilic, meaning they're attracted to fats, so they can easily cross cell membranes and permeate throughout the body. Now the body is a complex system, constantly striving for balance. So when these hormones are introduced, our bodies work to metabolize them. This primarily takes place in the liver, where enzymes break them down into metabolites. The next step is excretion. The kidneys play the lead role here, filtering out these metabolites and excreting them in the urine. But it's not all smooth sailing. Like most medications, adrenocorticosteroids come with potential side effects. These may include fluid retention, high blood pressure, mood changes, and even an increased risk of infections. That's why it's crucial to use these medications under the guidance of a healthcare professional. Corticosteroid antagonists, on the other hand, are used to counter these effects. They work by blocking the receptors that corticosteroids bind to, helping to mitigate some of the potential side effects. However, these antagonists aren't without their contraindications. They should be used cautiously in patients with certain conditions like liver disease or in those who are pregnant. Understanding these hormones and their antagonists can be crucial in managing various health conditions. It's a fascinating world where biochemistry meets medicine and where understanding can lead to better health outcomes. So there you have it, a glimpse into the world of adrenocorticosteroids and their antagonists. Subscribe for more because you won't find me later.